Hi, I'm Oliver Gao. I'm the director of Cornell Systems Engineering Program. I have been fortunate enough to conduct what I call these systems conversations with our prestigious speakers that we bring to Cornell to give a talk on system-related topics. So today I'm very delighted and honored to have Dr. Renzo Akkerman, who is an associate professor in operations research and logistics at Wageningen University in the Netherlands. Actually, earlier he was professor in operations management and technology at the Technical University of Munich, and an associate professor in operations management at the Technical University of Denmark. So actually, his research focuses on food supply chain management, which, by the way, is a great interest area of myself. Mm-hmm. And the specific topics range from efficient resource utilization in food processing to the design and planning of food supply chain, considering food-specific characteristics. So, Renzo, it's great to have you here. I would like to, I think I was looking at, the research coverage. That's certainly a very important system challenge that our whole humankind is facing nowadays, right, across the world. So, speaking of this, I think I would like to know more. Like, would you like to talk more about, how your career developed and how, like, your research has been led to addressing these kind of food-related systems issues?
Yeah, well, first of all, thanks for having me here. It's a pleasure to be visiting Cornell. I've been trained in operations research, so I guess most people familiar with the domain. So very much engineering focused, mm-hmm. But and from the start during my PhD, I've always been working with food industries. Mm-hmm. So when you talk about sort of production and logistics systems in the food environment, where a lot of interesting challenges come up, because if mm-hmm. we're shipping food products around, and we have to consider that these materials, they change in quality while we do that, and that's within production systems, within supply chains. So a lot of it, also in my early research, had to do with production planning and production scheduling, to try and optimize the food production systems from the sort of production side, and then later on also started doing more and more sort of logistics issues, looking at transportation networks, and also how can we model also product quality decay throughout these transportation systems, because mm-hmm. that we're obviously not just delivering some like components or parts for machinery, but we're delivering products that change and that maybe are affected by the temperature along the way, and that we all want to take into account in planning these supply chains and these production systems. So, mm-hmm. so that's sort of where I came from, and over the years it's been also shifting more and more towards sustainability considerations, mm-hmm. because there's a lot of issues with product losses and food waste when you look at food supply chains, and that mm-hmm. And that's obviously an important challenge that we also have to deal with from an operations research perspective and a supply chain management perspective.
Mm-hmm. That's great. Thank you very much, Renzo. So you mentioned, it sounds like kind of ever since your PhD, you started kind of doing research related to these kind of food systems. Mm. Of course, I think as a researcher, you definitely have the freedom to choose whatever topic that interests you the most. So now I would like to ask, why food systems?
Yeah, it's you're right in the sense where if you're thinking from our field as sort of operations research, industrial engineering, these type of approaches, then you can look at all kinds of different industries. Because the food industry is something that we all interact with, and mm-hmm. It's something where when I was talking about food quality and there's also food safety. There's a lot of, say, specific characteristics of this industry that make the planning and logistics very challenging. Mm-hmm. So that's one of the main reasons I started focusing on that, and that's also at my current university. You mentioned I was at Wageningen University in the Netherlands. That's traditionally started as an agricultural school.
Mm-hmm.
Like Cornell has a very strong profile in agriculture and food. And so, of course, in this position, it also is is an environment where there's lots of opportunities to work with the food system.
Yes.
That doesn't mean I haven't done anything elsewhere. So you mentioned I worked in Germany for a while. It's hard to avoid working with the automotive industry, for instance, while you're there. They also have interesting challenges, but it's a different environment than the food production, food supply chains.
Mm-hmm. Yeah, I think you mentioned. Thank you for answering my question. I think you mentioned that there are certain specific characteristics in the food systems that make the research very interesting. So do you want to give some examples of those complexities that excite you when you apply all these OR research tools to address the food system challenges?
Yeah. So it's some years ago we also had a very extensive survey when we looked at the literature focused on food supply chains, and then we also identified that there's basically three key aspects that people look at. People look at food quality, people look at food safety, and people look at sustainability as sort of three key characteristics that anything that has to do with food production and food supply chains has to consider. And that also means that these aspects we have to take into account when we develop our operations planning methodologies, for instance, or if we do transport planning, then these are the aspects that play an important role. And I've done a lot in relation to quality in the past, and I'm still doing that somewhat. But in the last few years, I've been focusing a bit more on the sustainability aspects. That people are very interested also in where does my food come from, how far has it traveled, and so there's concepts like food miles that play a role, and what impact on the environment do I have when I buy a certain food product, and should we source local food or not? That's people are often very attracted to these concepts, and there is some value in it, but there's also a lot of challenges to come up with efficient food supply chains, because we still need to feed a lot of people on this planet in an environmentally friendly way. So and that's, I guess, linking a bit to a larger system, if you will, in terms of food supply chain management.
That's wonderful. So I think the kind, with the food, of course, I mean, food is close to every one of us, right? I think it's cool. I would like to kind of probably direct our discussion to both a high level and a low level questions.
Yeah.
At a higher level, it can see it's kind of especially since you mentioned sustainability, right? We're looking at these things. If you look at food system, on one hand, of course, right? So kind of we have all this growing population, and they have growing need as well as increasing level of living standard. For which food will be so important. So on the demand side, we have all this growing demand, not only in quantity but also in terms of quality of this demand. And then another thing is on the supply side, right? So food is not only, of course, here you and me, we study like logistic related, supply chain related. However, another big thing is really supply side, like production, the production of the food. So, which means, of course, the production of the food, we need to use like fertilizer.
Yeah.
We need to use irrigation system, and even if we don't use fertilizer, but we still use, for example, farms, we use like kind of animal manure to to fertilize the land, and of course that could pollute the water, right? So for this, on one hand, we do want to satisfy human needs. Food consumption, but on the other hand, this production that could pose a threat or a challenge to sustainability. On the top level, what's your philosophical thinking in terms of trading off and balancing in this demand and this kind of production side?
So this I I have to preface this by saying that this goes sort of a bit beyond the scope that I normally work, right? If you think about this sort of system level, but I think that that a lot of discussion here is about what scale of a system are we looking for? Huh? So there's our university at the moment has a big initiative, what they call circular agriculture. Mm-hmm. So you're looking at cycles, and then of course that also involves fertilizer and manure, and where does that go? And sort of the nutrient depletion in the soil. That's all part of this food system, this agricultural system, where you want to replenish these resources, mm-hmm. And that might mean that at the moment there's a lot of product flows on a global level, but the question is also, if you move towards more local food production, for instance, to what extent can you close these cycles on that sort of larger system level with soil nutrients and things like that on a smaller scale, or is that not possible? So then we're, I don't know, if you look at maybe for me in Europe, maybe Europe is a good scale. Maybe we don't want to close the cycles within our own small country of the Netherlands. So that from a systems perspective, we're in the systems engineering part of Cornell here. So there's a very complex system then, obviously, and that's and so far we're addressing parts of that, because if we were talking about a supply chain, then of course you have a system with some production companies, and you have to make decisions on suppliers, and you have to make sure what markets do we cover with our products. So you're operating within that system, but you're often still only looking at a subsystem and trying to still contribute to that larger discussion. And that's I think the decisions on for the future, what is the good scale on which we have these circular systems, mm-hmm. And sustainable systems, that is an important discussion, and a difficult one.
It is. I think it is a difficult one. That's why we're still doing research, right?
True.
Yeah, in these areas. So now coming down to the ground level, right? I say there is supply side, there's demand side. In between, mm-hmm. It's really supply chain.
Yeah.
Right?
That's what we do.
Right. It linking the supply chain, and you mentioned like we want to address, those challenges. You talk about the food safety, food security, and of course food system sustainability. Mm. So within the context of addressing these challenges, what role do you see supply chain play in addressing those challenges? Why? So again coming back to why supply chain? And if kind of food system is so big, and why supply chain is of this much interest to, and what do you think, with your research, how this supply chain improvement can help address those overall systems challenges?
Yeah, I think in the field of supply chain, we're very good at creating sort of the structured approach to analyze the material flows in these type of systems, and mm-hmm. And obviously if you go towards sustainability and sustainable supply chains, then the supply chain context often changes. It's not so linear anymore. So mm-hmm. There's often a lot more actors involved. So if I'm processing a food product, if it's based on plants or animals, there's a lot of different materials that and products that come out of these raw materials, mm-hmm. and they go to lots of different markets, and then maybe somebody else can use one of the byproducts. So there's it's not a very linear supply chain anymore. There's a lot of actors that are also using each other's maybe waste streams or byproducts. So you get a lot of links maybe across supply chains. So that creates a more complicated supply chain environment, but it's still, for most of our modeling purposes, if we try to capture this in say quantitative modeling approaches, it's still a supply chain that we can analyze, and that I think is a very helpful tool in also to quantify some of the efforts towards sustainability, and so to put some numbers on that, because there's a lot of gut feeling about what's better for the environment or climate, if you want to look a bit broader. Then, but it can be very hard to quantify that, and I think that's a place where, in our field, we are well positioned to do that. So I don't know if that answers your question.
I think that's wonderful. No, I think that's wonderful. So you mentioned, all these kind of. I think you're right. Actually, a lot of times the concepts, if you tell some kind of basic idea of the concepts to even non-researchers, they will get it immediately, and even possible. However, how when you get this concept to the level of supporting decision making, and I think one key thing, as you mentioned, is quantification.
Yeah.
Right. Oh, it's going up or going down, but by how much?
Yeah.
At what cost? And whether it's cost-effective decision. I think that's where really our work will come in. So speaking of this, look, when you were trying to optimize like the food supply chain system, whatever case that you look at, so I'm just thinking, what would be like the major benefit if we are able to optimize the whole supply chain? So I was trying to drive to the direct. I know that, for example, in the U.S. I think all over the world, when people say, "Oh, we have this serious kind of poverty issues," and we think about this poverty, and we think about this kind of nutrition issues, and a lot of times you will hear, "Okay, we need to improve our production. Yeah. We need to produce more. Yeah. We need to use digital agriculture. Yeah. Whatever new technology to improve our production." Yeah. But on the other hand, in the meantime, we also heard that, say, people that there are as much as 30% of the food produced being wasted. Yeah. Right. So in that case, kind of what I'm just thinking. Yeah. Just imagine how hard it is, given that we have already exploited our system to improve the productivity. I think it's probably very hard for you to come out with technology or agricultural system that can increase your production by 30%. So in comparison to if we can optimize the supply chain to help reduce that waste. Yeah. So if you reduce the waste, if you reduce that 30% of the waste in comparison to producing 30% more. So what do you see as the potential of this supply chain, not only modeling and management, but also kind of supporting the practice? Do you think that can help us resolve this kind of food waste problem?
Yeah, I think this discussion has several perspectives. There's one of it, if we're talking about sort of the whole supply chain and the food waste example, then and that's especially in the sort of the developed countries where we have a lot of waste at the end of the supply chain, right? So it's us as consumers that throw away a lot of food. So there, I think an important aspect is also the interdisciplinary work that is being done within sort of the supply chain community, more with consumer behavior aspects. So how does a consumer in a retail environment or at home treat their food products? And and if you think about retail, and that's some work that some of my colleagues in Wageningen are also working on. It's more what price incentives do we also have in a retail environment for like discounting strategies to try and avoid wasting products at that stage in the supply chain, and that partly builds on also having a good understanding of the consumer behavior in the retail environment and at home after they bought a certain product. So that I know, obviously from a systems perspective, we're making things more complicated again because we're enlarging the system, and we're adding more behavioral aspects into this system for for which we often end up collaborating then also with the sort of the people who are experts on that. We cannot do everything by ourselves. And I think another important aspect of what you mentioned is because you were talking about technological developments, and a lot of the work that I've been trying to do at least is also on the interface between, say, technology and management, because we can change technologies, but often that also means that we have to change supply chains around it. If we're able to process something more efficiently, or we don't have to process something on a large scale anymore, but we can, for instance, very efficiently make food products on a smaller scale, then maybe we can also do that locally. So then we reduce transport, but then we end up producing our dairy products, for instance, in a lot more locations than we do now. And so there's an interaction between the technological developments in sort of agriculture, food processing, and the design and operation of supply chains around these technologies, and that I think is a very exciting interface to be working on. So that I would say is also a key part of this discussion.
I think that's a very good point. I agree with you. It's kind of at the interface of the technology and the food system. I think there's a lot interesting kind of opportunity to be explored. So do you want to tell us kind of any recent work or study that you're excited, and like also the insights or the methods you applied in the work, so that I think we can probably dive a little bit deeper in your work.
Yeah, no, it's I know later today I will be presenting something in your seminar series, right? So that's I think a good example of a more operational problem, because I'm actually talking then about water usage, because when we produce food products, we're using a lot of water, and that's something that so far we haven't been really good at integrating that in our production management approaches. So if we're thinking about food processing facilities, if we're making the dairy products or beer or whatever kind of products we're looking at, we're using a lot of water in these production systems, and that integrating this water aspect, and especially sort of the reduction of water usage in the planning and control of these production systems, is a very challenging topic, and that from a methodological perspective is very challenging from an optimization point of view, because we've been using for a long time all kinds of mathematical modeling approaches to come up with optimal plans or schedules for our factories, and that that remains quite complex optimization models. But if you then add all kinds of additional complicating factors on top, like water usage or energy usage or these kind of approaches, then we're complicating that even further, and then we're even though we have pretty good computers nowadays, we're still running into problems solving our mathematical models. So how do we model these production systems in such a way that we can still operate them efficiently and with the lowest possible water consumption, for instance? That's challenging, and I think that's also from a modeling perspective. How do we capture these dynamics inside of these facilities in a good way in our mathematical models? That's an interesting thing, and that's something that is very, very specific, and even a system within factory walls in a way, if you think about it like that. And another thing I've been quite involved with over the last few years is something that in Europe we like to call the circular economy. I think in the US that term has not been used that much. I think you also talk a lot about the food, water, energy nexus here, and that but in Europe and then your and it's in the, sort of the academic community, but also in terms of policy making in Europe. There's a sort of a big initiative and a big push towards the circular economy, in which we try to reduce the amount of resources we use, or increase the reuse and the recycling of materials, and that obviously has a lot to do with supply chains again.
Yes.
And that and also creates a lot of new supply chains from materials that we might be able to reuse or recycle, and how do we then get those back into our production environments, and that goes from from plastics and paper that we've been already reasonably good in collecting, in terms of also for at the consumer level, but then that still needs to then feed back into production systems, and that's not always easy. There's lots of different types of plastic, so that gets mixed up, and it's all very complicated. But on the other hand, and that's a bit more towards the food supply chain discussion again, there's also a lot of organic waste streams and food waste streams, and a lot of those you can reuse again. There's very useful compounds in spent coffee grounds, in orange peels that you can use as an input to make new materials. Mm-hmm. But then you have to make sure to also collect that again. And there's a lot of initiatives of also startups that look into using these material streams, but they're often struggling with, say, the logistics and the supply chain, because then how do I collect this? Do I ask people to drop off their orange peels in some bin somewhere? Mm-hmm. So it's a very complex logistics network with often quite a lot of actors involved. There's hotels and restaurants that have the coffee grounds that you can use to make some product from. But that is something that we've been spending quite some time on in the last year or year and a half, on what are the supply chain challenges, and we haven't gotten that far yet into modeling them. That's still something that we're then trying to work on in the future.
I think that's wonderful. So sounds like as you are saying, when we enter into this circular economy, mm-hmm. Not only, of course, the paradigm will change, but also the supporting logistics mm-hmm. will be challenged.
Yeah.
And even in the research community. So of course, if you think it's still very traditional, like OR type of work, we have an objective function, mm-hmm. and we want to optimize this objective function with respect to some of the decision variables, of course, subject to all those different constraints. Mm-hmm. So now, if we think about these two cases, one is it's an open supply chain,
yeah,
right, front end and the back end, versus a circular supply chain. Mm-hmm. So between these two different modes of supply chains, when we go from this open supply chain to circular supply chain, mm-hmm. what are some technical modeling challenges?
Yeah. Yes, there's, and we also have to be fair and say that not all of this is new, right? So we've also in our sort of the operations community have been working on something we call closed loop supply chains mm-hmm. for quite a long time, and also thinking about the collection of the paper and glass and all these. So there's a lot of the logistics that we've already have a lot of experience with dealing and working with these materials, but I think there's a lot of new applications where indeed the systems are more open. It's not so much the material coming back into the same company. And with the circular economy, that you often end up with waste streams that are used for completely different purposes. So you end up connecting new actors within sort of larger complicated supply networks, and it's not possible to just run an optimization model and say minimize transport cost and then we're good. Mm-hmm. That's not going to work. So there's a lot of sort of additional layers of modeling that you would require to also model the interactions between the people in these networks. So in what type of maybe even governmental incentives do I need in these type of networks to improve, say, reuse or recycling of materials?
Games.
And then you can think about more sort of game theoretic work that you need to look at to analyze that. And that's from a modeling perspective, especially on the sort of the collaborations in this network and sort of the incentive structures that I don't know, maybe appear through government regulation or appear because I know, resources are becoming more scarce and more expensive. So that's also a changing incentive structure in these networks, and that there's, I think, still a lot of interesting things that we can do.
Yeah, I think. Thank you. I think you mentioned these kind of incentive structures, which I think, of course, I think it's going to be very critical, because just from a conceptual point of view, if I'm a company, right, I was producing, this kind of food product before, and I'm using, the water from the river nearby, and I use it, and I discharge it, the water gets polluted, but before, of course, you can see that this kind of social cost of this water pollution is not necessarily internalized to me as as a business owner, right? So this is probably the traditional challenge, right? When we try to think about environmental abatement from the sustainability perspective for any kind of production, including food production, somehow you can see that either it's a constraint or it's some kind of when we look at all those kind of environmental costs, to me as a business owner, right? So if you want me for my overall seed production optimization, if you want me to also consider that part,
you have to have a reason.
Yeah, I have to have a reason, and that part, just whatever, however smart researchers are to convince me, but to me in the end, it's going to be a cost in my balance sheet. So in that case, that's why, like I think, mentioned this kind of incentive. So of course, as researchers, you design these models, you do all these things. Now, my next question is, what are the challenges or the tips of success you have found out in your research to bring the research outcomes and insights from research to the real world application, adopted by practitioners, business owners, as well as the government? What are the challenges there? To people usually call this kind of the Death Valley of academic research, right? We write proposal. We work with students. We work out such a beautiful paper with all this creative thinking of this formulation. We feel excited. It end up in a very top journal, and then we stop there, and we go back to write proposal. So, however, I think, as you mentioned, how can we bring all these these exciting, all these kind of insights into the hands of the policymakers and the practitioners, such that our vision in the end becomes reality?
That's a very big question. Let me first of all say that, but it's also a very interesting point. And I think there's several things that play an important role here. One is that and that's maybe biased by my environment in the Netherlands, is that we, especially in our master's program, we do a lot of projects together with companies, and which means that a lot of the, for instance, master thesis projects end up in collaboration with companies, where students spend up to half a year also working with the company. So that some of the modeling work is then in a very much applied environment happening within these thesis projects, and that in these master thesis projects, they don't necessarily lead to top publications, but that's also not necessarily our goal in these projects. Then we hope to learn from that, again, to see what challenges these companies are dealing with, and on the other hand, we hope that the kind of modeling approaches that our students work with also help these companies, or at least help them quantify things. Because if we're talking about incentives for me to reduce my water consumption as a food production company, then it already helps a lot if I have a good quantification on what will it cost me if I want to reduce my water consumption with 5%, 10%, 15%, and that's obviously the type of things that we can relatively easily quantify using our modeling approaches. And then I cannot make the decisions for these private companies on how to use that information, but we can at least help quantify these aspects. And then I wanted to add another thing, which is I think again very much biased by my context in the Netherlands, is that our research funding more and more requires us to bring in companies on board in research proposals.
That's a good thing.
Early on.
Yeah.
And with a commitment in terms of time or money from these companies. And that means that throughout even already when you're identifying your research questions in your proposals, you have to have in a way a company sign off on it. Yes, this is an interesting question that I'm also interested in learning about for whatever reasons in terms of either it could be a sustainability thing, but this is a broader discussion, obviously. And that I think that helps also ensure that you're working on stuff that's relevant, and that and also the work I was talking about in terms of circular economy that we've done over the last few years. That was very much working with lots of different cases from the industry to see what kind of challenges there are. So that keeps us real in a way to see what is then the problem that we should be working on. Also what are the more generic challenges that come out of looking at many of these cases in a project like that. And that I think that that environment through sort of students and also in research projects is to linking with companies in an early stage. That definitely helps. And then we still have the traditional operations challenges in that you have to communicate complex mathematical models at some point, and then there's but that's I don't know if that's a topic we have time for here today, but there's often a bit of a black box issue with mathematical models that you have to see what do you put in, what comes out, and do I understand what's happening? But I think that's a very big topic we might not have time for today.
I agree with you. I guess probably I think after we're getting to a point, I think kind of it's going to be a big question, a big problem. However, I think it's probably interesting for us to poke into it a little bit. So I think again coming back to the keyword, I think incentive. I feel it's kind of that seems to be the key, right? Yeah. It's kind of because just imagine that for this kind of environmentally aware like supply chain management, and also as you were saying, in a circular economy, it's no longer just the supply chain of one company. Actually, it's going to be intertwined, weaved together. It's probably going to be a supply network, right? Not a supply chain.
True.
And which means that on this supply network, you have different stakeholders. For company, if along the vertical supply chain, you are probably hopefully like your interest is aligned, right? Of course, across the network, you have other stakeholders. Their interest might not be lined up with company A or company B, but they have to work together. Yeah. And then, of course, on the top, right, you have the government. Yeah. Making public policy, which is supposedly to kind of coordinate and design this kind of incentive and mechanism structure such that all this whole thing can be orchestrated. So of course, if ideally, behind the government, it's us, the general public,
Yeah.
because the general public we can vote, right? If the
Yeah.
right. So now you can see that we have this general public, the government, and all this industry supply network.
Mm-hmm.
Let's just limit ourselves to this food system, like
Yeah.
this,
All
this public, government, and this industry stakeholders.
Yeah.
And now, of course, when we look at supply chain, we can help, one industry or one company or a few to do this kind of optimization to help them manage this whole chain. And then after that, when all these different stakeholders will start interaction, and then we need to model that.
Yeah.
We need to understand how they interact. And also we need to understand how their interaction will be affected by this government policy.
Yeah.
So if you think about these different levels,
Yeah.
industry level optimization,
Yeah.
inter-industry optimization,
Yeah.
and government and industry optimization.
Yeah.
So where do you think the key, like if, as a researcher, we always want to find, because of course we cannot address all those things, but we want to find out the most valuable question, such that when that question is addressed, and then other questions, what do you see as some key, like research points where you feel researchers can really play very significant role?
Yeah. If you look at these different levels you're outlining, then of course the industry level is something that we've been working on for a long time. I think the sort of the inter-industry level is still something where we're working on, and where we're trying to also come up with sort of good means of collaboration. It could be collaboration in terms of transport activities, collaborations in terms of I'm using some of your products, and so that there's something that we are and we should be working on, and I think linking that then again to the sort of the policy level above that, if we're working on sort of industry level and inter-industry level, then we have a very good environment, in a way, you could almost see it as a simulation model that you can use to also analyze policy decisions, right? So because if we're modeling the interactions between these companies and potential collaboration structures, and then using those models and then see how they behave if you would put different incentives in place, that's a very useful way to try and also analyze the impact of policies inside of the modeling approaches we've maybe been developing for pure profit maximization in a supply chain with one company or maybe together with another company. So there's definitely opportunities to use these models to represent the dynamics of inter-industry behavior, also in policy analysis. I think that's something that we should be working on. I think, and that's most of the challenges for us are probably on the inter-industry links and how to operate those and how to design those properly. But then, based on the knowledge we generate there and the models and tools we develop there, I think we can also try to say something about how policy would relate to that.
That's great. I think our time is up, but I want to ask you this final question. Of course, you and me, while we're researchers, we want to address all those interesting questions. We also have another hat, which is we are educator, right? And you mentioned your, master program where you have students working with industry. So what would you say to our future generations, researchers or kind of professors or even practitioners, for them to be able to go out to overcome those challenges that you just listed.
Yeah.
What would you say to them when they are still here or still there at the university? What would you say to them so that they can make good use of their time at the university before they head out?
Yeah. So that this risks being an answer that's very much biased, of course, by my interests and my background, but I find it very useful to help students think in processes. And then if you're talking about systems, then I know a system consists of lots of processes, and that and I think in operations and industrial engineering we're also trained to think in processes with inputs and outputs. But even in this more complex world, where we maybe look at very big societal problems with, like we were talking about earlier, with the policy layer and different industries, that's still a system that's consisting of different processes, and maybe individual companies are in the end simplified as a process, but we need this multi-level analysis of basically processes to analyze this more and more maybe complex environment. That is something that I at least try to emphasize when I'm also talking to students from lots of different programs at our university.
I think that's beautiful. I think you pointed out this key thing. It's really thinking the processes. I think you're right. Everything, even complex systems, they will consist of all these different processes. But if the students, and even including us, if we are trained well to think about these different processes and actually understand the processes, and based on understanding, if we can design procedures, I think processes. Yeah. Understand the processes and design the procedures to do the right thing and do it right. Yeah. Yeah. I think that's wonderful. Thank you, Renzo. I think we had a nice conversation.
Yeah. Thank you very much.
Thank you.